Fault finding on a CAN, controller area network, bus system in vehicles requires a structured approach. Since almost every modern vehicle uses CAN to connect modules like the ECU, ABS, airbag, and body control, a fault can cause multiple warning lights or total communication loss. Below is a practical, workshop-style diagnostic guide. 1. Understand the CAN bus basics. Most vehicles use two main types: high-speed CAN, HS-CAN, powertrain systems, ECU, ABS, TCM, low-speed CAN, LS-CAN/MS-CAN, body systems, doors, lights, HVAC. A typical HS-CAN system: two twisted wires, CAN high, CAN-H, CAN low, CAN-L. Operates around 2.5 volts idle, both lines. CAN-H rises to approximately 3.5 volts. CAN-L drops to approximately 1.5 volts. Terminated by two 120 ohm resistors, total 60 ohms across the network. 2. Identify common symptoms of CAN faults. No communication with scan tool, multiple control modules offline, U codes, communication fault codes, warning lights across several systems, vehicle won't start, immobilizer via CAN. 3 step-by-step fault-finding procedure. Step 1. Global scan. Use a diagnostic scanner. Perform full system scan. Note, modules not communicating U codes, for example, U0100, U0121, which network is affected. If all modules are offline, then check power/ground first. If one module is offline, then likely that module or its wiring. Step 2. Check battery voltage. Low voltage can cause CAN chaos. Battery should be 12.6 volts engine off, 13.5 to 14.5 volts engine running. Unstable voltage can mimic CAN failure. Step 3. Check CAN resistance. Ignition off. Very important test. Turn ignition off. Disconnect battery if required by manufacturer. Measure resistance between CAN high and CAN low at OBD port. Expected reading, approximately 60 ohms. If you get 120 ohms, arrow, one termination resistor missing, 0 to 10 ohms, arrow, short circuit OL, open line, arrow, broken wire. Step 4. Check voltage, ignition on. Back probe CAN H and CAN L. Expected, CAN H approximately 2.5 to 3.5 volts. CAN L approximately 2.5 to 1.5 volts. If you see both stuck at 0 volts implies short to ground. Both at 12 volts implies short to power. One flat, one normal implies shorted wire. Step 5. Inspect physical wiring. CAN is sensitive to wiring condition. Check for twisted pair integrity, corrosion at connectors, water damage, aftermarket accessories, alarms, trackers, crash damage near front end. Untwisted CAN wiring can cause signal interference. Step 6. Oscilloscope test. Best method. Using a 2-channel scope, healthy waveform, mirror image signals, clean square wave, no excessive noise. If waveform, noisy to poor ground or interference, flattened to shorted module, one line missing to broken wire. Step 7. Isolate the faulty module if needed. If resistance is wrong, unplug one module at a time. Recheck resistance after each unplug. When resistance returns to 60 ohms, arrow, last unplugged module is faulty. Common failures: ABS modules, water damage BCM, airbag module after crash 4. Common CAN fault scenarios: short to ground, one line stuck at 0 volts, Network down, often wiring damage. Missing termination, 120 ohms reading. One module not powered. Broken wire between modules. Short between CAN H and CAN L, near 0 ohms reading. Entire network fails. Intermittent fault. Vehicle works until vibration. Loose connector. Corroded splice joint. 5. Important diagnostic tips. Check powers and grounds to modules first. Checkmark. Never pierce CAN wires. Can cause corrosion. Checkmark. Do not use a test light on CAN lines. Checkmark. Disconnect battery before unplugging airbag modules. Checkmark. Check wiring diagrams to identify network topology. 6. Advanced checks, if needed. Check gateway module. Check star connectors. Verify network wake-up signals. Use manufacturer network topology diagrams. 7. Quick diagnostic flow summary. Full scan. Check battery voltage. Measure CAN resistance, 60 ohms. Check CAN voltage. Inspect wiring. Scope test. Isolate modules.